after looking at the detailed table of how to graph exponential functions, let's use this to figure out how to sketch. Once again, what makes this an exponential function is that we have a base with the x as being our variable. Now, I do want to point out, remember this being a function, as we said, it passes the vertical line test. As you can see, a vertical line is never going to hit this twice. And that's obvious because anything I plug in for an exponent is only going to have one output. There's going to be nothing that's going to cause it to fold back on itself or anything else. Now, when we want to graph f3 to 0, without even sketching, without even making a table, without putting a whole lot of thought, we do know it's going to start at 0, 1. The reason I know it starts at 0, 1 is because 3 to the 0 power is 1. Anything to the 0 power is going to be 1 always. This is always going to be our starting point. Now, when we started 3 to the 0, 0, 1, we're going to know it's going to get so steep so quick. It's hard to even graph these. In fact, much of the time when you graph these on multiple, like on the same TI graphing calculator, you're going to notice they get so much steeper, it's hard to even notice the difference. It's like an extra few pixels up near the top. These graphs get so steep so quick, it's hard to even distinguish the difference between them. This is the exponential growth side. Well, then we know that we have the other side where it's going to keep getting close to and close to and close to and close to. It's never going to touch and it's never going to cross. Remember, as we called it before, the asymptote side. And this is what exponential graphs will always look at without even going through the whole detail. Yeah, we could say 1, 3, 2, 9, 3, 27. These numbers get so giant. These numbers get so small. All of them are going to have that same form. In fact, even this other side, if you were to put on a graphing calculator, you'll see a few extra pixels here. You may not even notice the difference between a 2 to the x and 3 to the x when you graph those, just because of the exaggerated tails of each side of that function.